So this kind of goes with the release presentation. It's about unit testing and how it will save the world. Well, we'll get into it. So what is unit testing? Basically, it's running your code and trying to make things break. But more importantly, you want to break them in a way that's helpful to you, so that you have like information on how to fix it. What do you test? You can test the program as a whole. That's a good place to start. And then you can go down and you can test individual functions, or if you're like really paranoid, you can test code like line by line and make sure that it works as you meant it to. And so basically you take a program, you provide some input to the program or the function, and then you check the output and make sure it makes sense. So testing should be automatic. For example, with Saya, you just type make test, and you get a bunch of tests, and it says they all passed, because we don't have anything broken right now. Testing needs to be helpful. You can see a not helpful test here. I run the test and then just seg faults, and I have no information. If this is like a 20,000 line of code project, it's not helpful. So I do want to say testing is better than no testing. So it's better to have a test that says it's seg faults, that way you know it's broken. But really you'd like to have information about what's broken. So here I contrived a test where Saya breaks. You can see we get a message, message 0 never received. So if we go and we look at the code that's testing it, I don't know if you can see my mouse. We start by calling join Saya, then we check for an error, and we see if we got a message never received. So I know that somewhere when I called join Saya, something was broken. So that gives me a good idea where to start. I think join Saya is like 20 lines of code, so pretty painless debugging there. And so the purpose is to like save you headaches. You find out if it's broken right away. You don't have someone who's using it emailing you like why is my stuff not working? And then it automatically finds bugs. And one of the big things to test code manually. Before on MTVSynth, we didn't really have unit tests. So I'd write code and then I would go through and I'd like try videos by hand and I would compare the outputs. And with unit tests, you just type test and it just does it all for you. So it's much easier, much nicer to program with. And so part 2, you have it automatically tests when you change things. So for example, with Saya, we had to swap out the crypto libraries due to seg faults. This ended up with like 15 different functions being changed. So I changed them all, there were errors, and then I got rid of all the errors, and then I ran the tests, and the tests were saying certain things weren't working. So because Saya has a very good testing system, it was very easy. It took me like 30 or 40 minutes tops to fix a whole bunch of things. So it was very nice compared to standard debugging. And I think I already went over this. So what do you test? You test the program as a whole. That's sort of your like baseline test, and then you might go through and test each major part. And then depending on how much testing you want to do, you can go down and test functions or individual lines. So when you're writing tests, you want to start big and work your way down. So the first test you write tests all the pieces working all together. The second test you write is like the individual large components. When you're running the tests, you want to run them in the opposite order. So run the small test first. That way, if say if the network's broken, you see that message before you see the whole thing's broken. It just gives you better feedback to run it that way. So how do I write tests? It really depends. If you're using Golang, it's really nice. They have a testing package, and I know it's just built in, and it's really nice. If you're using something like C, you're going to have to write a bunch of separate executables, or maybe one monster executable that just goes through and like tests each function by hand and then spits out output of whether it succeeded or failed. But for the most part, every language has some sort of standard for running tests because unit tests are very common. So generally, whatever environment you're in, someone's going to have advice on the best way to do testing. So how much testing is good? It really depends. So how big is the project? How many people are working on it? How long will people be using it? And so like the bigger the project, the more tests per line of code you want. So because if it's a small project, it's easy to keep it all in your head. If something breaks, it's going to be easier for you to mentally like transverse the code and imagine what broke. If you're working with like 15,000 lines of code, it's a lot harder to mentally go through it, and so you want your tests to be stronger and better. And then how many people are working on it? If you have like 2 people working on the project, you don't need too much testing, you just have some. But if there are like 30 people, a lot of times you might be writing code you're unfamiliar with, you're going to want the tests to be a lot more solid. Then how long will people be using the project? Obviously longer means more tests per line of code, and then how important is it that the project is bug-free? We actually have an example. So example 1, 1,500 lines of code, you're the only person who uses it, you don't care if it's a little buggy. And just like write 1 or 2 tests, just make sure the whole thing works. Pretty simple. Example 2, it's like a giant project with 70 people, and it's like a medical project. So if there's a severe bug, people could die because the surgical tool fails or whatever. So in this case, you'd want to have like more tests than code. Like every function needs to be thoroughly tested. You need to test for seg faults. You need to hit it with null inputs and just like, you know, Armageddon code, right? Armageddon testing. So yeah, basically it's an optimization problem. You take your project and you figure out how much time should I be spending on testing, because it's really easy to get, you know, go down the rabbit hole and test too much and waste time. So the other thing is benchmarks, which I would say most projects don't need to worry about benchmarks, but it's like a similar vein to testing where you just see how long each function is running, and you help also like code profiling, you find out where it's slow. So I'm just going to leave that behind. You can look that up on your own. And then finally, we already went through Travis CI today, so I'm actually just, it's great. Here's a picture of Saya. Luke's trying to merge code. It says build passing, so I know that he didn't break any of our tests, so I can merge. Thanks.